if you've seen my prior talks on embeddings and so forth at .fmp and the like, this is pretty much entirely different. So it is going to deal with embeddings. From chatting to a number of people, I think it sounds like a lot of people aren't sure about different use cases for embeddings. So there will be a point at which I'm just going to run through a number of slides that list potential use cases for embeddings, just to give you ideas. Kind of that's in addition to the other stuff that I've got in here. So I suppose I should probably, with that kind of warning, I'll just get started. So I'm Ian, a Canadian, but I live in the centre of London. Basically, I've been working with FileMaker just about forever. I spend most of my time thinking about technology and reading and playing with AI at the moment. For the last 4 years, I've been doing a lot of work looking at extracting meaning from unstructured data. And when I did finish my MBA in 2020, it was on business strategy and machine learning. And from the photograph you can see from when I was 10 years old, Canadian kid, I was probably the worst hockey player in Canada. And that was just about the age that I stopped playing when I stayed that height and everyone I was playing against grew 4 inches. So I stopped, I think, the year after that photo, which was no big loss for hockey. So what I'm going to talk about, I started off by looking at ThoughtWorks is it's sort of very high-end software engineering firm. A lot of the thought leaders in the industry, people like Martin Fowler, who have written a lot of books on how to write software, work there. Every year they come out with a technology radar, which is basically what's the state of play in the technology landscape at the moment. And I've taken that, and they break things up into techniques that you should adopt, techniques you should trial, assess, and there's many more than this. And at the end, I should probably share the link to the documents. It's really, really interesting. But I've picked 2 items out of techniques that I think are quite applicable to FileMaker. And the first one, which they categorize as something we should be looking at adopting, is retrieval augmented generation, or RAG. And then they're suggesting that we should trial function calling with LLMs. And so those are going to be sort of the 2 main topics that I cover today. In addition to that, we're also going to, I should say that these techniques are both, they're achievable with the current shipping FileMaker product, which is a good thing. And everything here can also run with a local large language model. And the demos that I'm going to show you basically were recorded with everything running off my MacBook M1. So no connection to OpenAI or Anthropic or any other provider needed. It was all local, running off a system called Olama, which that'll kind of be a third topic that'll fit in as and when. So if we start off with retrieval augmented generation, basically what we're looking at is our data plus an LLM. I'm not going to go into great detail like in my prior talks on the scripts in FileMaker. I'm just going to go more on kind of the architecture of how things go, because I think at this point most people have probably already seen presentations on the specific script steps in FileMaker that we use and can play around with that if they want to. So first off, an LLM isn't a database, so we cannot rely on it for facts. Large language models, LLMs, are really, really good at generating text. And so if we're interested in a system that deals with facts, where do we get the facts from? And we're going to get them from FileMaker. We are at a FileMaker conference, so that kind of makes sense. So I've taken this definition of retrieval augmented generation. Again, this is from the ThoughtWorks technology radar. Basically saying with RAG, information about relevant and trustworthy documents is stored in a database. For a given prompt, the database is queried. the documents are retrieved and the prompt is augmented with the content of the documents. So we've got richer context for the LLM. But it doesn't need to be documents. It could be information out of your database. So a lot of us have, earlier on, Andy was talking about the contents of notes fields that he said he was trying to get rid of for years. But actually now those things can be used as the source for this information. So the components really are, we've got an LLM, we've got a database, and we've got a vector database. FileMaker now can fill both the database and vector database functions because they've got the ability to perform searches on embeddings. So it can deal with the vector side of things as well. And I'll just show you a quick demo. And what I'm going to demo is something I've been working on. I'm going to apologize in advance for the interface because it's kind of a hack together sort of thing. But fundamentally, what I've been working on is a system that extracts information from meetings, meeting transcripts, allows you to aggregate them, to query them. So essentially, we're going to be able to perform RAG against meetings. And apologies for the volume of this, but sort of the front screen, this is actually, so what I've got here is I've got some recordings of lectures from my university course on the operations management. So if I just play this, it'll just sort of give you a sense of what we've got is we've got a video player.
Through to the more interesting ones.
In
they
FileMaker,
talked about integrated, where actually what you've got is you've got tight velocity coupling and high homology where they're all clustered closely together. Because what you're seeing is you're seeing massive increases in terms of the technological capability, which impacts the product, which impacts the demand. And in turn, you've got fairly high barriers to entry. So all of these affect the other things. So you've got tight coupling. But again, because of the kind of independence of them, they all move roughly at the same speed.
We can jump back and forth.
So the food producer, yes.
The video.
So LeBron's written, I think it's important to mention the horse meat's normally more expensive.
Sorry, so we can perform semantic search on that. So if we look for a build or buy decision, that's going to search across all of these videos. It's going to find these ones as these are the video segments that have got answers. Clicking on that basically jumps to that point in the video and starts playing
don't have to build something unique.
Sort of that segment.
You need to solve a problem.
So that sort of gives you a bit of a sense of some of the stuff you can do. So what I'm doing is basically taking video, audio, PDF, Word documents, PowerPoint, Markdown, essentially any kind of document you can think of, extracting the information from that, embedding that, and basically we've built sort of a set of tools that communicate with the LLM, and at the end, we can sort of extract insights from it. The first phase of things is our data preparation. So let's say we've got our data in FileMaker. Basically what we do is we get the embeddings from it. In this case, sorry, I'm like Ryan, I need to stay over here. We get the embeddings. In this case, I'm using Ollama as the local LLM. FileMaker requires that the embedding API be OpenAI compatible. Ollama, for about the last 2 months, has actually implemented an OpenAI compatible embedding API. So you can now use Ollama not only for local LLM, but you can use it as a local embedding API server as well, which is really handy. And some of the options there for models are the all mini LM, nomic embed text. There's a number of different models we can use for embedding. Anyway, we get these embeddings back. We store them in FileMaker in container fields, because that's the right way to do it. And that's kind of the data preparation side of things. I've kind of glided over the whole topic of chunking. How do we break up the text into appropriate sizes of chunks? Because to be honest, that's like probably a 2-hour session in and of itself. But there's a number of different strategies we can use for that. So just to recap, vector embeddings, we take an object, we feed it through an embedding model, and what we get back is a vector of numbers, a string of numbers, which we store in the vector database, and that can then represent kind of the contextual meaning of what the text or the file that we passed in. So FileMaker's said that you can now use images as well in search, which is true. That's primarily actually been an issue of the model. It's basically you need to use a model that is specifically works with images. Something like ClipVec, sorry, I can't remember off the top of my head. Some of the ClipVit model, I believe, is one of the ones that they've used to vectorize images. And when we come to query, let's say the user goes to query FileMaker. The next step is basically we pass off to, again, we get the embedding for the text that we're querying. This needs to be using the same model that we've used for embedding our data in the system. And that passes that back to FileMaker. We use the perform a semantic find script step, which can find the embeddings. That gets us sort of our set of records that we're looking at. You can do this on the full set of records in FileMaker or on the found set. And in the case of RAG, what you would then do is you could then take that data, sort of pass that over to the LLM, which could then summarize that. And in this case, again, with OLAMA, you could use Llama 3.1, Gemma 2, a variety of different models to summarize the text. And you get back your summarized answer in FileMaker. You can combine vector search with keyword search to be more effective. So you would narrow down your set of records with keyword search where possible prior to doing your vector search, and you'll get better performance, and you'll get better find results in general. You can also, as Andy said, you can also find records that are similar. Because we've already got the vector embeddings stored in FileMaker, you can take the vector embedding for a record and then perform a search looking for items that are similar to that embedding. And so in that case, you don't actually need to talk to the embedding server at all at this point. You can just do that entirely within FileMaker, and that would then sort of show you the set of records that are similar in meaning to the ones that you've already viewed. Or if we're dealing with images, it would show you images that are similar. Yes, Heidi? For the user query, yes, that's correct. Actually, I should have actually rephrased that, so it says find similar rather than user query. Thank you. So RAG addresses several problems. It can address the issues with hallucinations from large language models because we're passing it in known information. We've got the domain-specific knowledge for your organization that we're passing in. It also addresses issues with knowledge cutoff because LLMs are trained up to a certain point, so they know nothing past that point. And it also helps with sort of issues of context window size of how much information are we passing in. We have potential issues we need to think about. What happens if we have conflicting data? What happens if the data that we found, that if we've got conflicting answers within the data set we pass to the LLM, it has no way of knowing which is correct. Likewise, what happens if the data that we've embedded and sent to the LLM, what happens if that conflicts with information that the LLM has? If it believes one thing, but our data says another, which wins? I don't have answers for these, by the way. LLMs are not very good with dealing with things like temporal context, like when did things happen or the order things happened in. So these are things to be careful of. And they also seem to get easily confused if you're asking questions, whether you're looking at aggregated information or specific instances of information, that I've found that can be tricky to deal with at times. That may just be that I'm prompting it poorly, but that's one thing I found. So anyway, so why is semantic search, why is it a big deal? Because it makes our searches context sensitive. And if we take an example of, let's look at Netflix. I want to see films with a strong female lead. So if I search for this on Netflix, this is what I'm expecting. I want to see Alien and Kill Bill, films like this. And what I actually get from Netflix is a black screen telling me that it's found no matches. So this kind of search screen would be much more powerful and useful with semantic search, with contextual search, of understanding what I'm looking for. So, was that it? No, okay. So,
when you fill this kind of database with this information, would there be any remarks on this film is about a strong woman? Who concludes that it's a strong woman in this film?
it essentially would be from the description of the film. That basically, the description of the film, let's say, for example, if we took Alien, the description of the film Alien, there's enough information in the description of that film that a semantic search would be able to see strong woman or strong female lead from that description of the film. So we can get an enhanced user experience. Now, this is a bit where I said I'm going to run through a load of screens of use cases that sort of may be a little bit out of context of everything, but potentially could be useful. So with image embeddings, we can do image search using natural language queries. We can classify images into categories defined by text without needing to train the information. We can deduplicate images because we can find images that are similar. We can cluster images that are similar. We can find images or videos that are similar to given query. We can also perform object recognition. I think somebody once in one call suggested that if you had a copyright owner who owned, like they could look for instances of their copyright appearing in images, like say for Coke, for example, could find the Coke logo if it was being misused, that type of thing. Recommendation systems, you can suggest products similar to those viewed or purchases. You can compare user preferences to embed them and compare that against the embeddings for products or videos. And you could also then find similar behaviors or similar users and potentially recommend based on what they've seen. We can classify text to group similar topics. We can perform text clustering. One of the other things, actually I didn't show it in the video of what I've done, was when I was doing my studies that I basically had all these interviews with people that basically I was extracting common themes from. And so those themes actually basically by embedding those themes and the content of what people said, we can find all of the things that it's easier to group the text and what people said into those themes or extract new themes even. Because things can work across different languages, we can potentially use a machine translation. With fraud detection, this is a big use case for things like banks, but they look for anomalies, things that are sort of outside the normal patterns of behavior. Social media and content moderation, you can find content, sentiment analysis, trend analysis. E-commerce and retail basically allows semantic search for products. You could match the customer profiles again to products, potentially optimize inventory. And then for research, we could look for similar documents, similar concepts. Because the feature in FileMaker is described as semantic search, actually, in a way it makes you think about searching for text. But if you think of it as a way to find similar things or similar stuff, similar text or similar images, that's another way that maybe might sort of trigger more potential use cases for people. Okay, so that was kind of like my quick whistle-stop tour through a RAG. We're kind of part two, which is going to be the more contentious part. This is going to be the part that some people here are probably going to say, you're wrong when you're doing this wrong. But I'm going to proceed anyway. And I'm going to talk about LLM and tool calling and where do they fit. So originally I was thinking about, I titled this sort of using agents with FileMaker, and it's not really using sort of full-on software agents, but the term agents at the moment seems to be quite conflated with tool calling or function calling. So for the purposes of this, I've more or less kind of saying they're kind of the same thing. And the tool calling and function calling is a building block necessary to do agentic systems. So that's where we'll start. Oh yeah, so my clickbait title. So again, this is from ThoughtWorks, their definitions. AI agents, programs designed to work autonomously to achieve certain goals, whereas tools in an LLM, basically, you're integrating LLMs with external functions or tools by determining and invoking the appropriate function based on a given query and documentation. And so what we're going to do is we're going to see how we can do that in FileMaker, or do that with FileMaker. So yeah, again, clarification, the agents are autonomous, goal-oriented, adaptive, proactive, and the data tends to be persistent, whereas tools they're very focused on a specific task. And so you'll see what people refer to as agents, often they're tools that have got a very clear specific task that maybe they're using several tools to achieve their goals. They're quite limited in the scope, they're reactive, and then the data is ephemeral. So the data doesn't persist. So tools, really, we've got sort of these inputs into a process that gives us an output. And because it's software, these things are actually composable. So the outputs of one can be the inputs to another. And so that's how we can kind of construct something moving more in the direction of agents, if you will. So with agents, basically, there needs to be something orchestrating everything. And we could potentially do some of that in FileMaker. So we use FileMaker scripts to coordinate the actions of these tools that we're going to use. The way I'm going to tackle this is I'm going to show you a quick demo file. It's going to take about a minute to run. And then what I'm going to do is I'm going to break it down and I'm going to show you step by step how I built that. So what you're seeing is basically I'm doing, would help if I hit play. There we go. Recording text into FileMaker in a web viewer, which is using the Whisper model to transcribe it. We're saying, tell me which tools are available in FileMaker. It's talking to the LLM right now. The LLM comes back, and it's basically saying, these are the tools I've identified that are available. Oh, the audio's, I stopped the audio, sorry. So that's, essentially I've told it I was interested in the sales of sweatshirts. It basically came back and it ran a FileMaker script to show me the sales of sweatshirts. The next thing I'm saying is I'm interested in red sweatshirts. So it now goes off and performs a script, and it's shown me the sales for red sweatshirts. And the next thing I want to do is ask it for the salary of the CEO. So fundamentally what we've done is we've recorded audio. We could have just typed it into a field. However, recording it and transcribing it is much cooler, so of course I had to do that. I basically built a prompt out of that, sent it to an LLM. The LLM, based on the tools that I told it were available, came back and said, these are the things you can do. And we'll now have a look at how do we do that. So yeah, we did real-time audio transcription with Whisper. So I'm using a Whisper model locally on the Mac. It is not talking to OpenAI. It's a bit easier to do with OpenAI, but again, it's not local. We're using a local LLM, and the LLM decided which scripts to call in FileMaker. So the basic process is we've got a user question, the available tools are combined into a prompt, we send that to the LLM, and the LLM then, based on that, says, given this prompt, this is the tool that I should use. So the technology I've used, basically we've got FileMaker, we've got JavaScript in the web viewer, Whisper for the transcription. I'm basically got a fast API for a Python API, and then we're using Ollama for embedding and the large language model. So step by step, okay, so the user starts recording. We've got a JavaScript, we've got a web viewer that's got JavaScript in it. Basically in HTML5, HTML5 has the ability to record audio into a web viewer with JavaScript. So that's what I've done. It then asks the user for microphone access. In my demo, basically, if the user says no, it just kind of breaks down and stops working. But if the user accepts it, then it starts recording. And it's setting up a WebSocket connection to my fast API endpoint, which is written in Python. The WebSocket is sending, I've said 8K chunks, but it may be 4K chunks of audio. So it basically is sending these little chunks of audio to the endpoint. The API basically has a function in it to detect when the speech is stopped, when someone's finished speaking, and when the speech stops, it then passes all of the audio onto the Whisper model. And I'm using the tiny Whisper model, which on a MacBook M1 is pretty darn close to real time. It's really, really fast. I tried the large model, but the large model took about 5 or 6 seconds to do the transcription, which it seemed like a long, long wait when I tried it. So the trade-off there is that the tiny model has poorer performance in terms of accuracy compared to the large model. So yes.
Is there a reason, or is there a way to do that with audio recording in container fields?
Oh yeah.
Container fields?
The question was, is there a way to do this with audio files that are recorded into container fields? And yes, there is. You could basically just simply pass the entire container field, the contents of that, along to the Whisper model, and it would return the answer. Yes. Okay. So the Whisper model, it's actually the API that returns the transcribed text. And in this case, I'd said the first command was, tell me what functions you can perform. So it returns that back to FileMaker, to my JavaScript code, which is then pops that into a FileMaker field. So we've now got our transcribed text into a field. We could have just typed it there, but again, not as cool. And we now then need to construct a user prompt to send to the LLM, and the LLM will decide what do we do with this user's request. So the LLM is running locally on MacBook Pro M1 in Ollama. So if there's a bit of repetition here. So basically, yeah, so now FileMaker, we've got JavaScript code, FileMaker script sends a request using insert from URL. It's a JSON request that we send. Ollama has an API, the same as OpenAI, that we can send requests to. So we do that. I'll go into more detail on the request in a second. So we're asking the LLM which tools can handle user prompt. We need to tell it which model to use. We have to tell it which tools are available because it has no idea. And we tell it what the user asked. And what I've done, tools in this case are simply FileMaker scripts. So I've got a table of FileMaker scripts. You can see there are 3 FileMaker scripts. We've got the script name, a description of it, and then we've got the script parameters. Down here, we've got a tool description, which is basically a JSON object that I've calculated from this information. So we construct a JSON object that describes the software tool. Fundamentally, all it's doing is it's saying, if you want to run this script, these are the parameters you need. And this is the script name. Because FileMaker, we can run scripts by name. And I'm sure many of you use that already in your systems. So the calculated field describes it basically in the correct format so that we need to pass. We've got sort of our tools, a list of parameters. It's an array of parameters. Basically, we've got the parameter name, the parameter type, and is it mandatory? We've got the script name and the description of the script. So the description of the script is really, really important because that's what the LLM is going to use to decide, should I use this or not? If we've got a bad description for this, it's not going to work very well. So we tell it what tools, what parameters, which ones are mandatory, and we do this JSON. Now, because we're building up this script, the JSON query programmatically, it ends up getting really big and really messy, so I've kind of broken it up into smaller parts so you'll actually be able to see it on screen. So the prompt looks like this. We need to tell the LLM that we want our answer back in JSON format. It's really, really important. Like that's mandatory. It just won't work without that. You need to tell it which model. And it's really, really important that the model has to support tools. Not all of them do. And the models that support tools are capable of returning a result in JSON if you tell it you want it in JSON. Because LLMs are all about dealing with text, many of them are not very good at giving you back JSON as a result. So the models that deal with tools sort out that problem. We've got our user input in the prompt. We're telling it to stream false, so we don't want to receive the answer in bits and pieces. We want to just receive one answer in one big chunk. And then we've got a system prompt, which I will show you on the next slide. So the system prompt is something we construct. It's got two parts. We've got an overall instruction, and then we've got a list of tools. And for each tool, we tell it the script name. I've missed the script description, but that should be there as well. The list of parameters, the name, required, true or false, and then the type. And so it ends up looking like this, which is broken down into parts again. The overall instruction starts off like summon your helpful assistant, blah, blah, blah. But you're seeing that what you're saying is that you're taking a question and finding the most appropriate tool or tools to execute along with the parameters required to run the tool. If you cannot find a relevant tool, respond as JSON with error, no matching function found. That could be anything you want. If you do find a relevant tool, respond as JSON, and you give it a schema, function name, the parameters, and then down here, then we give it the tools are, and we're giving a list of tools. For each tool, we give it the description, the name, and then the parameters. So in this case, you can say the description was view the historic sales for a specific product and color, the script name, and then the parameters. And we need to describe the parameters pretty well as also, because the LLM's got to take our user query and it's got to extract the parameters out of that. So not only does the script need to be described well, but the parameters need to be described well. So in this case, my sample data set, what I found was that things like t-shirts were referred to as a T, not t-shirt. And there were a lot of little issues like weird edge cases like that. So things like, and I also had to say, do not include the color in the product name. So the structure of the data seems to affect this quite a lot. And I think this is kind of why they're saying this is one of those things that you need, maybe you should be investigating, not implementing, because it's sort of it's a bit bleeding edge. So the tool describes how to call a FileMaker script. And, right, so we've sent our request to the LLM, which will respond to the request back to FileMaker. And we're parsing that response. And the response looks like this. For the query that I showed on the initial query, Basically, it's come back with a response saying the function name is tools underscore describe underscore available tools with an empty list of parameters. This shows a response, the view historic sales, which is a FileMaker script name, and then we've got our parameters. We've got a parameter name, product, the parameter name is a product, parameter value is a sweatshirt. We've got a second one, parameter name, color, parameter value, red. So what we do basically on our FileMaker script is we parse this, and this is what our script looks like. And down here, we're basically then, that FileMaker script that was returned as the function name, we perform script by name, script name, and we pass in our parameters, which is a technique that I'm sure everyone is pretty familiar with in a lot of cases anyway. So FileMaker then runs our script. So again, the technology used, we already did. So that sort of shows you roughly what needs to be done to do that. So essentially the steps are that we take our user prompt, we combine that with other information about, well, basically a list of scripts that we're letting the system run from the LLM, packaging those up as JSON with the parameters needed, handing it off to the LLM and saying, from this list, from this set of options, you choose the best one that most fits the user query. And it then picks the script that fits best, hands that back with the parameters, or if it doesn't find one, then it hands back the JSON we structured sort of with the error message. So the LLM could be hosted, could be local or on AWS in your infrastructure. And I'll sort of go on and sort of show you. So Olama is an app that hosts LLMs locally on your computer. It's very easy you just basically download and install it. You can run it at the command line. So this is a simple example here, the command line. Olama lists all the models. So these are the models that I've got installed on a computer. And basically I say Olama run Gemma 2. That's now running an LLM on my local. So basically I'm saying, write me a poem about Malmo. Oh no, FileMaker in Malmo. So performance isn't as good as the large hosted models actually, but that's pretty darn good for running locally on this. I've become a really big fan of Olama as a way to run the models locally. And the fact that it now, because it's got an API and is an embedding API, it's also the simplest way to do sort of embeddings locally. Now, if you're running a PC versus a Mac, you've got a little bit of an issue because this can take an advantage of the GPU on a Mac. Most PCs probably don't have a GPU. And for LLMs, you really, really need to have a GPU. If you're putting this stuff on, say, on a FileMaker server, the issue you've got there is that most FileMaker servers are not going to have GPUs unless it's a Mac server, in which case the M series is kind of built in. So you've got a number of options. So for FileMaker, you really, really want to have the OpenAI compatible embedding API, and your two options there, actually not quite, you've got Olama and LM Studio. LM Studio is similar. You can basically download it, install it, and it will run LLMs on your computer. FileMaker has also got their open source embedding API that comes with FileMaker server. It's a bit more tricky to install. Wim has got a good article describing how you install that. Essentially, you need to configure it with a JWT token for authentication, and you also need to set up the SSL certificates correctly. So it's a little bit of a a faff to do that, but that'll run sort of on your FileMaker server, no problem. You've got other options with API, but no embedding API. I wouldn't really worry about those. Olama is just super, super simple. You basically go to olama.com, just click download. It's an app that will run, and it'll run in the background on your computer, and it's available sort of when you want it. I'm really, really impressed by it. And the pace of change is, they're really doing a lot of work on developing it. So performance considerations, you need to have a GPU. Memory is a big one. So I've got 16 gigs of RAM on this MacBook, and what that means is I'm constrained on the models that I can run. I can only run some of the smaller models. Models are referred to, say, for example, 7B would be 7 billion parameters. The larger models, say 70B, would be 17 billion parameters, but I'd need to have probably over 90 gigabytes of RAM to run a model like that, which clearly I don't have, but that's why you're now seeing new Macs coming out with more RAM, because they're, with Apple Intelligence, basically they're wrapping up LLMs, needs more memory, and that's why. So, yeah, so the model choice is, the thing is, the more, broadly speaking, the more parameters the model's got, the more accurate it's going to be. So it's a trade-off, memory performance, and the smaller models are also faster, but less accurate. So, just so like quick recap. So we've had a very quick whistle-stop tour through RAG, just looking at the architecture. The slides that I've got here have changed quite substantially from the slides that were uploaded. So what I'm going to do is I'm going to talk to Joris and Johan about getting updated slides with the modern stuff. And then we've also looked at sort of function calling with LLMs, which you can do in FileMaker as well. So at that point, questions. And I think Mark has got the microphone in the back. I should actually say that Nicholas is going to show up a presentation tomorrow where he talks about Hugging Face models, where he corrects everything that I said that was wrong today.
Hello.
Hey, Stathis.
That was a great presentation, Ian. Thank you.
Oh, thanks.
I just wanted to brainstorm an idea that just came in mind thanks to that presentation. What if you fed the LLM with MBS documentation and you just had a loop that could evaluate every line?
So do you mean to query the documentation, or are you talking about basically trying to write?
No, like you told the model that here are the available functions. What if you fed the whole MBS library, maybe just a selection of it, and then you could say, create 5 records of that, and then insert
because MBS actually evaluates text, doesn't it? You're basically passing in text.
Exactly, yeah. So you could, like, if it returned one line as a MBS function.
I don't know. Why don't you try it tonight and tell us tomorrow? I don't know. That's a cool idea.
But could the LLM be fed with that big documentation?
Actually, given the documentation size, probably not. They're just thinking, because most LLMs have sort of an available context size, an amount of you can sort of stuff into them. And I'm not having looked at the monkey bread documentation for a while, but I'm guessing that it's probably enormous.
Yeah.
I'm not sure.
The microphone.
Yeah. So.
You could probably do something like categorize, use some metadata to split it up some, right?
Yeah,
So
you probably could. Yeah.
Yeah. And then
Yeah.
you wouldn't run into that problem.
Yeah, but that's an interesting idea, because You could, yeah, because you basically could sort of populate a function as well if you, but again, you'd have to just tell it what functions are available. And Philippe has got.
Just following those lines, how about feeding a save as XML file and getting all the help and structure and information about your solution out of that?
That is basically, I think, what Vince's Inspector 8 does. So Inspector 8 takes the XML format, and he's now added semantic search into Inspector 8.
But that's not the point. I know what Vince is doing with Inspector Pro. I was just thinking that the LLM could write my help file for my solution.
Oh.
Because it knows what my solution does from the XML. The layouts are there, the scripts are there, the buttons are there. Just write me a help file.
Yeah.
Possibly.
At least, I think that if you want to do it, that is a good idea. You have to make a model and train it, because other case, probably the structure of the help file that you will find out will not be, let's say, accurate. But if you have a model, you put the different FileMakers or other products help solution, and you train it, probably you have a good result. But you have to train. Other cases can be split out on different ideas. I mean, the problem is that a general model is not accurate enough, perhaps, to be trustable at the end if you don't train it more specifically on your model. This is what I guess.
Yeah, because what I'm going to say is even that simple example I had there, some of the prompting and the descriptions of parameters to make it work consistently was a bit more, it was a bit more work than I'd expected.
I have one question that is a bizarre one, perhaps. I have not made any exercise on trying on the new Apple M2 or the new GPU models. Did you have found that they are much more fast or faster than the one, or you have a difference between the M1 and 2 on the GPU sense when they have to calculate of the embeddings and this kind of stuff? Because I don't know if really worth the money to invest in equipment. I mean, in local equipment, let's say a laptop or whatever. I'm trying to really understanding make sense. I mean, for someone who wants to work, you know, on a specific place without connection, to invest on a very heavy or let's say expensive machine, it really makes a difference of M1, because nobody has done I didn't find any on the net that someone says the difference really on these LLM models to try to use the GPUs, the new ones, Apple GPUs.
What I have seen are that the new ones are faster, but also I guess what I'd not understood before was the difference in the Apple CPUs and GPUs, that the big difference between the regular models and the max models and the ultra models is essentially the memory bandwidth. That the ultra models and apparently the new series M4 chips apparently have got a lot more memory bandwidth for dealing with the models.
See,
so
I don't know if the problem also is that the code that I mean, if you use the NVIDIA GPUs, I mean, you have your coder in the backside that you code, but these ones, I don't know how they are built on they have to translate to Coda or Coda to those native. I don't know really how it works.
yeah, I'm not sure, because a lot of stuff, like, say, at a lower level, say, like if you're using sentence transformers in Python, for example, a lot of that stuff is really heavily optimized for NVIDIA.
Yeah, I know. Everybody is optimizing for NVIDIA because it has a kind of monopoly, no?
Yeah,
okay.
yeah. Yeah, I'm not sure. They seem to be faster, but it's, again, quantifying. I guess we'll find out. Marcel.
I would like to ask a question about the semantic search you described in the first part of your presentation.
Yeah.
We have a use case to classify some product images, a lot of product images, and is there any good way of injecting the description of the products together with the image to have a better result with the embeddings? Is there any best practices you can recommend how to put in the data to get the embedding back? The question behind it is, if you just feed the images, you can search for similarity or some basic things, but if you need specific description, diameters of technical stuff or whatever.
Because the other thing is that actually with the image embedding, the models like ClipVit, one of the things they're doing is they're downsizing the image as part of the embedding process, and they're downsizing it to something that's really small, like a couple hundred pixels square. So if you've got large detailed photographs, that embedding, I don't know how that's going to work.
Okay, yeah, thank you. So we have
so
to find kind of best fit to
yeah, I don't have an answer for you, sorry.
That's okay, thank you.
Any other questions? Or have I just... Okay, thank you very much for your time.